At Granger, we're for the ones who specialize in saving the day and for the ones who've mastered the art of keeping business moving. We offer industrial-grade supplies for every industry with same-day pickup and next-day delivery on most orders, all backed by real people ready to help. So you can get the right answers and products right when you need them. Call, clickgranger.com, or just stop by. Granger, for the ones who get it done.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 24, Episode 108, for broadcast on the 24th of September 2021. Coming up on SpaceTime, time for a revision on the Milky Way galaxy's formation, NASA's James Webb Space Telescope ready for launch, and it's hard to believe, but it's already been a year since the death of the Arecibo Radio Telescope. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists are going to need to rethink how the Milky Way galaxy formed and evolved after new observations showed that the galaxy's gases aren't as homogeneously mixed as originally thought. The findings, reported in the journal Nature, have surprised astronomers who thought the different gases that filled the interstellar space between the stars would have mixed reasonably well over the galaxy's 12 billion-year lifespan. The authors found three main gas elements stand out. There's the pristine gas coming from outside the galaxy. There's the gas between the stars inside the Milky Way, which is enriched with the elements produced by stars. And then there's the dust created by the condensation of metals present in these gases. For astronomers, all chemicals other than hydrogen and helium, the elements produced in the Big Bang itself, are referred to as metals. Until now, theoretical models assumed that these three groups of gases were homogeneously mixed throughout the Milky Way, and that they've reached a level of chemical enrichment very similar to the Sun's atmosphere, what astronomers refer to as solar metallicity. However, the new observations by astronomers from the University of Geneva found that these gases are not mixed as much as previously thought, and that has a strong impact on science's current understanding of the evolution of galaxies. Galaxies are made up of a collection of stars, and are formed through the condensation of gases in the intergalactic medium composed mostly of hydrogen and helium, with only trace amounts of metallicity, unlike the gas inside galaxies. As intergalactic hydrogen and helium gas falls in from the outside under the influence of the galaxy's gravity, the pristine material forms new stars inside the galaxy. At the same time, other stars already shining in the galaxy are busily producing metals through nuclear synthesis, either during their lives or when they die. These metal-rich gases are then expelled across the galaxy to become part of the material used to create progressively newer generations of stars. When these gases move far enough away from a star, they'll cool down and condense into cosmic dust. Now, initially, when the Milky Way was formed, it would have had virtually no metals. But stars gradually enrich the interstellar environment within the galaxy with the metals they produced, a process which continues today. The amount of metals in the gas gradually builds up over eons, and the level of metals currently present in our Sun is referred to by astronomers as solar metallicity. Until now, theoretical models suggested that these three separate groups of gases were homogeneously mixed and reached the Sun's composition pretty well everywhere within the galaxy, with only a slight increase in metallicity towards the centre where stars are more numerous. But the new observations, using spectrographs on the Hubble Space Telescope and the Very Large Telescope in Chile, haven't shown this. Spectroscopy splits light from stars into a rainbow of different frequencies. Each frequency is based on a specific chemical composition, and that allows scientists to determine what a star's made of. But it's not that simple. Some elements are a lot easier to detect than others, and so a new dual observation technique had to be developed to allow the authors to see what's happening with these three different groups of gases. They found that the Milky Way's environment is not homogeneous, and some of the areas studied reached only 10% of solar metallicity. And what all that means is that different groups of stars and planets in different parts of the galaxy would be very different from those found in other parts of the galaxy. And that's before we even include those stars and planets cannibalized from other galaxies through galactic mergers. All in all, it's painting a far more complicated picture of galaxy evolution. This is SpaceTime. Still to come. NASA's James Webb Space Telescope ready for launch. And hard to believe, but it's now been a year since the death of the Arecibo Radio Telescope. We'll have a look back at this iconic piece of infrastructure. All that and more still to come on SpaceTime.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
After successfully completing its final tests, NASA's James Webb Space Telescope is now being prepared for shipment to the launch pad. The $10 billion orbiting observatory is slated to launch aboard an Ariane 5 rocket from the European Space Agency's Kourou spaceport in French Guiana on December the 18th. Put simply, James Webb will replace Hubble as the world's premier space science observatory. It's the largest and most powerful space telescope ever built. But whereas Hubble looked mostly in visible light, James Webb will focus on the infrared. That's because it'll be capable of looking so far back in space-time that light from distant stars would have been stretched into the infrared by the expansion of the universe. Looking back over 13.5 billion years, James Webb will see light from the very first stars and galaxies that formed just a few 100 million years after the Big Bang itself. It'll solve mysteries in our solar system, look beyond to distant worlds around other stars, and probe the mysterious structures and origins of the universe and our place within it. Engineers have now completed James Webb's extensive comprehensive test program at Northrop Grumman's Redondo Beach facilities in California. These tests were designed to ensure that the world's most complex space science observatory will operate as it's meant to once it's in space. You see, unlike the Hubble Space Telescope, which is in low Earth orbit and could be serviced by the Space Shuttle, James Webb will be positioned some 1.5 million kilometres away, and so too far away for any problems, such as Hubble's nearsightedness, to be corrected if they show up. For a telescope as complex as James Webb, shipment operations to Kourou will be extremely complex, with specialised contamination control technicians, transport engineers and logistics task forces working together to protect the telescope during transport. While shipment operations are underway, teams located at Webb's Mission Operations Center at the Space Telescope Science Institute in Baltimore, Maryland, will continue to check and recheck the complex communications network it will be using once in space. After Webb arrives in French Guiana, launch processing teams will then configure the observatory for flight. This involves post-shipment checkouts to ensure the observatory hasn't been damaged or contaminated during transport, carefully loading the spacecraft's propellant tanks with the hydrazine fuel and nitrogen tetroxide oxidizer it'll need to power its rocket thrusters to maintain orbit, and attaching all those remove before flight red tag items like protective covers that keep important components safe during assembly, testing and transport. Only then will engineering teams mate the observatory to its Ariane 5 launch vehicle, before it finally rolls out onto the launch pad, ready for flight. After its 26-minute ride aboard Ariane, the spacecraft will separate from the rocket and automatically deploy its solar arrays. It'll then begin a 6-month orbital commissioning phase. The all-important sunshield deployment will begin a few days after launch, and there'll be numerous subsequent deployments as different bits of equipment slowly unfold over the following weeks. Webb will take a month to reach its intended orbital location, 1.5 million kilometres from the Earth, in what's known as the Lagrange L2 position, a gravitational well on the opposite side of the Earth to the Sun. Meanwhile, once the sun shield starts to deploy, the telescope and its instruments will enter shade and start to cool down. Mission managers will be carefully monitoring this cool down phase, using heaters to control stresses on the instruments and structures. In the meantime, the secondary mirror tripod will unfold, the primary mirror will unfold, Webb's instruments will slowly power up, and thruster firings will insert the observatory into its prescribed orbit. Once the observatory is cooled down and stabilised at its frigid operating temperature, several months of alignments of its optics and calibrations of its scientific instruments will begin. As for scientific operations, if all goes well, they're expected to commence about 6 months after launch. Fingers crossed. This is SpaceTime. Still to come. It's now been a year since the death of the Arecibo Radio Telescope, and a Russian rocket has blasted off from Baikonur carrying another 34 OneWeb Internet broadband communication satellites. All that and more still to come on SpaceTime. Well, it's hard to believe, but it's now been a year since the iconic 305-metre Arecibo Radio Telescope in Puerto Rico first began snapping support cables, a process that would ultimately lead to the collapse of the main dish on December 1st. For decades, Arecibo held the title as the world's largest radio telescope. It was primarily used for research into radio astronomy, atmospheric sciences, and radar astronomy, as well as being a key part of the SETI program's search for extraterrestrial intelligence. And of course, it's had starring roles in several movies, including Contact and the James Bond thriller GoldenEye. I guess the first signs of problems to come really became apparent in 2006 when the giant dish suffered a significant funding cut. But problems really began when damage was caused by Hurricane Maria in 2017 and a series of earthquakes struck the area in 2019 and 2020. The alarm bells really began ringing loud and clear in August 2020 when a key auxiliary cable supporting the massive suspended structure suddenly snapped, crashing down onto the collector dish. Tests showed the cable break happened at just a fraction of its rated capacity. Then another secondary supporting cable suddenly snapped in November. Engineers determined it would now be too dangerous to attempt repairs, and the only option left was the decommissioning and dismantling of the dish. But before that work could begin, several of the remaining support cables failed, and the supporting structure, antenna and dome assembly all fell onto the dish in a thunderous crash, destroying the telescope. Joining us now for a look back at Arecibo is Jonathan Nally, the editor of Australian Sky and Telescope magazine.
This was the one that was suspended on wires inside this valley in Puerto Rico and had been there for
305 metres across, yeah.
Yeah, really giant. And then the poor thing just collapsed. It was really quite sad to see and, of course, distressing for
it was heartbreaking.
Everyone who's been involved with it.
It was about a year ago now. It was heartbreaking.
Yeah, it was December last year, and I mean, a lot of Puerto Ricans, worked there, or their school kids visited there, and they were extremely proud of this amazing, enormous, gigantic radio telescope. So anyway, we take a fond look back at the 50 plus years of its history and some of the discoveries it made and the things it did. And we have a look and see whether there are any ideas maybe they might rebuild it.
That's Jonathan Nally, editor of Australian Sky and Telescope magazine. And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope magazine from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your letterbox or inbox. Subscribing's easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. This is SpaceTime. Still to come, OneWeb's internet constellation continues to grow. And later in the science report, engineers are developing a new lithium-sulfur battery that could let you drive from Sydney to Melbourne on a single charge. All that and lots more still to come on SpaceTime. A Russian rocket has blasted off carrying another 34 OneWeb internet broadband communication satellites. The launch aboard a Soyuz 21B rocket with a Frigate M upper stage took place at the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan. The spacecraft was successfully placed into orbit at an altitude of 1,200 kilometers. This was the 10th launch for OneWeb, brings to 322 the number of satellites in their growing constellation. The company plans to eventually have 588 of the 150-kilogram Ku-band satellites in orbit, plus a few spares. Right now there are 4 more launches planned to complete the initial constellation. The next will be from the Vostochny Cosmodrome in western Russia next month. That'll be followed by another Baikonur launch in December, and then 2 more launches, one in late December, the other in February, from the European Space Agency's Kourou spaceport in French Guiana. This is SpaceTime.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
And time now to take another brief look at some of the other stories making news in science this week with the Science Report. Researchers have discovered that smoke from Australia's black summer bushfires 2 years ago have spawned a massive phytoplankton bloom as large as the contiguous United States. A report in the journal Nature found that smoke from the 2019-2020 wildfires have travelled thousands of kilometres across the Pacific and Great Southern Ocean before finally falling onto the sea surface. On landing, it seeded a huge phytoplankton bloom between New Zealand and South America, covering an area thousands of kilometres wide. Meanwhile, a second paper has found that the Black Summer fires released twice as much carbon dioxide into the atmosphere as previously estimated, surpassing Australia's normal annual fire and fossil fuel emissions by 80%. A joint Sikorsky-Boeing team has submitted its Defiant X rotorcraft design as their contender for the United States Army's future long-range assault aircraft program. The program's designed to replace the current iconic U-860 Black Hawk helicopter. But the Defiant is a very different type of aircraft, a compound coaxial helicopter. Its main competition appears to be Bell's V-280 Valor tiltrotor. The US Army wants a next-generation rotorcraft with a cruising speed of at least 519 km per hour and a combat range of 556 kilometers. A new study has found that a spoonful of sugar helps the lithium last longer, at least a dozen lithium-sulfur batteries. Scientists at Monash University have used a glucose additive on a positive electrode to produce a longer-lasting, lighter, more sustainable rival to lithium-ion batteries. The discovery, reported in the journal Nature Communications, could ultimately mean an electric vehicle that could finally have a reasonable range, say about 1,000 kilometres instead of the current 100 or so. Now that would be the same as driving from Sydney to Melbourne on a single charge. It also opens new horizons for drones and submarines. In theory, lithium-sulfur batteries could store up to 5 times more energy than lithium-ion batteries of the same weight. But the problem's always been that the electrodes have deteriorated rapidly. That's due primarily to substantial expansion and sulfur compounds contaminating the negative lithium electrode. Paleontologists at the University of New England have revealed a remarkable new specimen of fossilized dinosaur skin. The skin belongs to a Camatosaurus, an 8-metre-long carnivorous theropod dinosaur known for its strange skull and large horns. These dinosaurs lived during the late Cretaceous, between 72 and 69.9 million years ago. The dinosaurs' remains were discovered at a dig site in Patagonia back in 1984. And in addition to the fossilized dinosaur bones, paleontologists were astounded to discover sections of fossilized dinosaur hide as well, an incredibly rare find. A report in the journal Cretaceous Research claims the fossilized skin included areas from the shoulders, the belly and the tail regions. The authors say the dinosaur skin has proven to be far more diverse than what scientists had previously thought. It includes large, randomly distributed conical studs surrounded by a network of small, elongated, diamond-shaped or subcircular scales. And unlike more recent discoveries of feathered dinosaurs, Carnotaurus was entirely scaly, with no evidence of any feathers. The United States Constitution's First Amendment prevents the government from making any laws which regulate or prohibit religion, freedom of the press, freedom of assembly, the right to petition the government to redress grievances, and freedom of speech. But what does freedom of speech really mean? And how applicable is that in Australia, which isn't governed by the constitution of another nation? Tim Mendham from Australian Skeptics says it's an issue which Australian governments have now been addressing.
After the run-ins with Facebook and various groups like that putting up information about anti-vaxxers and things that promote the anti-vax message, etc., the government brought in the Australian Code of Practice on Disinformation and Misinformation, which started in February of 2021. That was about 12 months after the federal government asked digital platforms, which is the Facebooks and that sort of stuff, to develop a voluntary code. Obviously, the voluntary code didn't work out too well, so they put out an actual government-mandated code, which is basic. The idea is, it's part of a reform generally of the technology and information dissemination landscape, as they call it, to actually tidy up and sort out the rubbish and the conspiracy theories and that sort of stuff that is spread around indiscriminately by social media. Comes up with the argument against it, of course, of free speech, blah, 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 all that sort of thing. The trouble is there is no such thing as free speech. It's never formally endorsed in any documentation, including the UN Declaration of Human Rights. I should point out that people obviously don't read the Universal Declaration of Human Rights, but there's a caveat in there that free speech is good, but you should not have free speech when it hurts others.
Well, you shouldn't yell fire in a theatre and things like that.
It's not just that. That was actually, that was an example used by a US senator, I think. But yeah, it's about that you can't spread information around that is going to hurt other people under the guise of free speech. And this is what religious discrimination and all these things are about. You should be able to hang around and say you will die because of your bad beliefs, or I will arrange people to make sure you will die, which is a threat, under the guise of free speech. There is no such thing as absolute free speech. Never has been, and probably never will be. And you can look that up, and we've written about that, and I've written about that in the Skeptic magazine. It's a fact of life. There was no Bill of Rights in Australia, and in the American Constitution, in all sorts of constitutions, the freedom of speech, which is a theoretically good thing, always has the caveat. And that's where they're applying here, or supposedly applying here, or trying to apply here with these social media platforms. You're allowed to demonstrate your point of view, but not with something that's going to hurt other people. And that goes back through philosophy and through practical experience through the decades and centuries and millennia of human existence.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel. And on Facebook, just go to facebook.com/spacetime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.